Hello everyone, I hope all is well. In this video, we are going to be talking about section 13.5, which begins on page 882, and the title of this section is Apply the Law of Sines. So in a previous video, I did a little bit of an introduction working through example 1, and I'm going to continue with that example and then move forward with other applications of the law of sines. So, going over the law of sines again, the law of sines can be used to solve triangles when two of the angles and the length of any side are unknown. So this is known as the angle-angle side or angle-side-angle cases. Or we can also use it when we know two sides and an angle opposite one of those sides, which is known as the SSA case. So in geometry, we talked about a couple of different theorems that allowed us to prove triangles congruent, and one was side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. And one case that we discussed that we couldn't actually use was that side-side angle. Or if you spelled it backwards, because it's spelled a dirty word. So we can't use this theorem to prove triangles congruent, which just makes it a very interesting case with an application of the law of sines. So we'll talk about that when we get to example 2 here of we can't use it to prove two triangles congruent, but we can use it to solve a couple of different options for the lengths of the sides and the measures of the angles. So let's go ahead and look at example 1 again. Solve triangle ABC with angle C equaling 107 degrees, angle B equals 25 degrees, and then side B, which is opposite of angle B, is 15. So you should be able to draw a picture, which I highly recommend with every single case here. Alright, so the first thing you need to do is find your missing angle. You know that all three angles in a triangle add up to 180 degrees. That is the interior angles. Alright, and then you can set up these proportions using the law of sines. Alright, and the one that they use is with the unknowns in the numerator, which I discussed in the previous video. That is the easiest case. So here, I do have the entire B side of the proportion, so I should be able to break it into two proportions, that one to solve for A, and this one to solve for side C. Okay, so moving forward, you break it into two equations, each with one missing variable, and then you solve each equation. So how they go about that is they go ahead and they multiply by that denominator. So over on this side, it's the sine of 48, and on this side, it is the sine of 107. So they multiply each side by that function. Alright. And these are going to cancel out. So I am dividing, so I'm going to undo that by multiplying. And that's how they get this step. Alright, so this is the exact answer. And then as soon as you type this into a calculator, it's going to give you a nice rounded answer. Alright, so you can round to 1 or 2 decimal places, whatever your directions tell you. The conventional is probably 1 decimal place. I normally like 2 because I just like to, go to the cents. I like to go to the hundredths. Alright, and so when they ask us to solve the triangle, you're finding the missing pieces. So I found the missing angle and the 2 missing sides. So let's do a couple of guided practice. Go ahead, pause the video and try to see if you can find the missing measures. I'm just going to keep flipping through some solutions here. Alright, so we have made it to example 2, the side-side angle case. Two angles and one side determine exactly one triangle, which is why we were able to use angle, angle, side, and angle, side, angle in geometry to prove two different triangles congruent. However, when you are given two sides and an angle opposite one of the sides, it may determine no triangle, one triangle, or two different triangles. So this is what is called the ambiguous case. So if this YouTube video doesn't do it for you, if you type in the side-side angle ambiguous case, you should be able to find other videos that relate to this content. So there are different possibilities here, and we've got to break it down with a nice little checklist. So what is the measure of angle A? All right, is it obtuse or is it acute? So if it's obtuse, we're going to go to this side of the chart. If it's acute, we're going to go to this side. And then we have to do a little bit of math, and we need to find H, which, if you are looking, what is H? What does H stand for? Hopefully you've seen that perpendicular little right angle there. H stands for height. All right, so when you are calculating height, it's going to break it into a couple of different cases. So you are looking at the two side lengths that they give you in order to analyze whether you're going to have no triangle, one triangle, or two triangles. Okay, so consider the case that A is obtuse. So let's go ahead and talk about when A is obtuse. All right, if A is less than B, no triangle can be created. All right, and that's just simple as far as the side's not long enough to go ahead and, touch the other side here. So I can't even physically make a triangle. And then the next case is if A is greater than B, then I am going to get one triangle. All right, so whatever I end up calculating, that is 100% for sure, those measurements. In the other case here, if A is acute, so I have something like 60 degrees. Okay, so my angle A is acute. I have a couple of different options. So I go ahead and calculate H, which is B sine A, and then I, classify it. Was H greater than A? Was H equal to A? Was H less than A, which was also less than B? So B is the greatest value. And is A greater than B? So we're just classifying it and kind of seeing if we're going to get, one, two, or no triangles. All right. And it being the ambiguous case is why we can't use it to prove two triangles congruent, because it could produce a completely different triangle. All right, so example 2. Solve the side-side angle case with one solution. So I have one solution here. So angle A is 115 degrees, which means it is obtuse. So I'm going to fall on that left side of the chart. And A is 20 and B is 11. So first, draw a picture. Draw a picture. All right. It doesn't have to be exact measurements in millimeters or anything like that, but you should know 115 degrees is going to be just past 90, not fully to 180, definitely closer to 90. And you know that side A has got to be longer than side B. And that's about all you can do from there. All right. So first make a sketch because A is obtuse and the side opposite of A is longer than the given adjacent side. You know that only one triangle can be formed. All right, and that was the simple A was greater than B part of that chart. All right, so moving forward, you can set up the law of sines here. So the sine of angle B, which you do not know, keeping in mind that the unknown is in the numerator, sine of angle B over 11 equals the sine of 115 over 20. And then you isolate the sine of B and type it into your calculator and you get approximately 0.4985. the more decimal places that you use and write down in this step, the better, and the closer it's going to be. So if you only round to 0.5 here, you are going to throw off your answer because we are not finished with the problem. So remember, when we round and then we type stuff in again and then we keep rounding, we are compounding the wrong answers. So what they do in the next step is they use that inverse sign function. So on your calculator here, if I were to clear this out, that's pressing the second button, and then that's pressing sign inverse. Alright, so you should be able to use that. So they take the sign inverse. What they don't write out for you is the sign inverse of 0.4985. Now, if you were to do this all in one step, here, taking this boxed answer, you could type in the sign inverse of 11 times the sine of 115, and then divided by 20. And that should give you pretty much the exact same 29.9 if you rounded. So I can go ahead and do that and see if I get out the right answer. 11 sine of 115 divided by 20. And I still get 28.8987, which is 29.9 according to them. Alright, so that gives us our missing angle, B. And then I can use that to approximate. Since I did round, I am approximating. Alright, and this should actually be an approximate sign too. Alright, I can use that to find angle C, which is going to come out to 35.1 degrees. And then I can use the law of sines again, so setting up another proportion, to find the remaining side length C. So since the side length is now missing, I want to go ahead and put that variable in the numerator using that reciprocal property of the law of sines again, and multiply each side by the sine of 35.1. Typing that all into my calculator in one step, I get C is approximately 12.7. And so then my final answer gives me my two missing angles and my one missing side. Alright, so looking at example 3 here, what if, they give us a big old hint with the title of it, right? No solution. So I should be looking out for, something that's going wrong, something that doesn't make sense. Okay, so I draw my triangle out. In my very first step, I draw it out. And A is 3.5 and B is 5. So since, according to, my chart here, A is acute, so I go to this part of my chart here that says A is acute. And I need to calculate, 100%, I need to calculate this h. Alright, so keep in mind h equals b sine of a. So I type that into my calculator, here's b sine of a, and I get 3.9. Since h is greater than a, that means that there's not going to be a triangle, no triangle. Alright, just a simple rule, h was greater than a, can't happen. So I move on to example 4. Let's look at two solutions. This one goes a little bit more in depth, but I'm still using the exact same process. I just have to use it multiple times. So let's make a sketch. First, make a sketch because b sine of a is approximately 10.3. Alright, so it falls into this category. H is not only less than A, meaning that there is going to be a triangle, but there's going to be two triangles, since A is between the values of H and A. Alright, so I draw out my two possibilities here. And the way that it's labeled, hopefully you can see that these two triangles are completely different. I do want to make sure to label all of my sides and all of my angles, including the ones that I don't have. For example, angle C and angle B as well. Alright, so use the law of sines to find the possible measures of angle B. So I set it up just like normal. Alright, with my unknown up in the top. I multiply each side by 16, type that into my calculator, take the inverse sine of both sides, and I get 52.3 degrees. So, that only gives me one value, so I'm a little bit confused as to how I could possibly have two different values. So here's what happens. The obtuse angle has a 52.3 degree angle as a reference angle. Okay, so recalling what a reference angle means. So either I've got 52.3 degrees here in this little triangle, or this reference angle is 52.3 degrees, but the triangle that is made instead is this one. Alright, so how do I get that? And the reason why that sign comes out to the same is because, remember, all students take calculus. That means in the first quadrant, all values are going to be positive, and here in the second quadrant, the sign's going to be positive. So all of that checks out. That I would get a positive 52.3 degrees as the reference angle. So I take that away from 180. Because I would be over here in the second quadrant. So I do 180 minus that 52.3 in order to figure out what this angle is. And I'd get 127.7 degrees. So I need to check out these two completely different options. Now find the remaining angle C. So since I have two options for angle B, I've got two options for angle C. And I set those up using their corresponding C values, and then I want to go ahead and find the two different side C's, depending on the different angle C's, depending on the different angle B's that I have. So I solve by multiplying the function in the denominator, and then I get two different answers here. So if B was 52.3 degrees, C would be 87.7 degrees, and side C would be 20.2. Whereas in triangle 2, if B was 127.7 degrees, C would be a lot smaller. Angle C would. It'd be 12.3 degrees, which would make its corresponding side C a lot smaller as well. So let's do a couple of guided practice. Feel free to pause the video and check your solutions here. Alright, so to our final concept of this section, it is the area of a triangle. You can use the following result to find the area of a triangle when you know the length of two sides and the measure of the included angle. So if you guys remember that very subtle vocab hint there, the included angle is the angle that falls between the two sides. So if I were talking about side C and side B here, the included angle is the angle that those two sides make up, which would be angle A. Alright, so if I've got, that would be that example. So I do have kind of this 1/2, if you remember the area of a triangle, that's 1/2 of your base times your height sort of situation. And tying that sort of piece in, if you remember, h equals b sine of a. H equals b sine of a. Well, here's b sine of a. If that's what I'm considering to be my height here, then c must kind of be my base, and then I still have that 1/2 piece. So it makes sense, the setup at least does, with the 1/2 and the two sides being multiplied and the sine of a, if I look at what we previously took notes on. So let's look at a couple of examples using these formulas. Alright, biology. Black-necked stilts are birds that live throughout Florida and surrounding areas, but breed mostly in the triangular region shown on the map. Find the area of this region. So, the area of this region, I have my lovely triangle set up here with A, B, and C. So, this is going to be little a, little c, little b. I do have sides B and C, and I have the included angle A. So, life is good. So, I'm going to be using this area formula and simply substituting in the values that I have here. 1/2 times 125 times 223 times the sine of 54.2 degrees. Making sure that my calculator is in degree mode. And typing that all in very carefully with my parentheses, I get approximately 11,300. Just to double check here in my calculator, because I know that they like to round at weird spots. I'm going to do 0.5. I like to type that in instead of 1/2 for the record. Alright, times 125 times 223 times the sine of 54.2 degrees, closing that out. Alright, so here's what I have. I'm going to press enter, and it gives me 11,304.20. Alright, so they're just rounding to the nearest 100. So don't feel like you're wrong if you got a little bit more there. Alright, so the area of the region is about 11,300 square miles. If you put 11,304 miles, I'd be good with that. So, go ahead and attempt these guided practice. Make sure that you have the included angle. Alright, so you should see kind of one of each sort of letter. Alright, that's a little hint for you all. So pause the video and see if you get matching solutions. Alright, if you guys have any questions, always feel free to send me an email and ask. Good luck!